Hey, Mr. P. Phelps, back with some algebra, Unit 4, Topic 1, Lesson 7. We're going to start off with some transformations. We are transforming. Transforming just means to move it or change it or make it slide. Transformations can be like, I think you've done slides and turns and what they call reflections. Well, either way, so they're translations, which are your slides, your reflections, and then you've got your rotations, which is like spinning. So we're going to do some translating, which happens to be sliding in this case. So x plus 3, 1, 2, 3. Plus 3 means it's right there. And it's got the exact same rate of change. And you're going to be doing this with non-linears as well. So you're going to see when we get to the next topic, when you're doing some quadratics in vertex form, you're going to see how the vertexes in vertex form, it actually is just sliding it around. It's just moving the parabola. So if you got that parabola, it's just sliding it around based upon whatever's in vertex form. X minus 3 means it hits at minus 3, 1, 2, 3 right there. And it's going at exactly the same rate also, which is at 1, up 1, right 1. And 3x is the only one that sees the 3, depending on where the 3 is. If it's plus 3, that means it translates it up. So it's the same as the pink line, but it's been raised up 3. If it's minus 3, then it's been moved down 3. But if it's times 3, that really just means 1, 2, 3. That just means that it's going up 3, right 1, up 3, right 1, or down 1, 2, 3, left 1. So it basically just means that the rate of change, it's going up faster. So whatever the coefficient is of the x means it's going to go up faster. If it was a fraction, it would be going down, up, it would be going up less. Or if it was negative, it would actually be going down in that case. Okay, so that was translations of linear equations. We're going to be exploring how things grow. This is basically just a review of everything we have done so far in this topic. Topic number 1. We're going to be talking about, is it a function? What type of function is it? What's the growth? And, what would another representation be? I'm not going to really focus on that one so much. So let's look at it. It says a plumber charges the base fee of $55 plus a service call costs $35 per hour. So that would be 35x plus 55. So that is a... Is it a function? Yes, it is. What type of function is? It is linear. What type of growth would that be? That would be plus 35 is the pattern. So you've got y equals $55 to begin with plus $35 per hour. This one's quadratic. Yes, it does pass the vertical line test. It is quadratic, as I just said. It would have second differences. It looks like it's decreasing, so it goes from here. So down 1, right 1. So it looks like it went down 1, and then it went down 1, 2, 3. Down 3. So it looks like it has a second difference of negative 2. All right, so let's keep it going. So it looks like we've got, this one is a function. If you put linear straight lines, vertical line pass, it passes. Yes, it is. This is exponential. It happens to be exponential decay. I know it's exponential decay because it's decreasing. If it was growth, it would have been increasing. So that's the type of function that is. This is quadratic, and I know it's because anything with x squared is quadratic. This one's exponential. This is also a function. This is what we call vertex form. So I know I mentioned that earlier. So that means that this is going to be transformed 2 to the right and 4 up. So imagine x squared looks like this. But this equation is not going to look like x squared. It's going to be slid 2 to the right because of this, and it's going to be slid 4 right. So the vertex isn't going to be at 0, 0. It's going to be right 2, up 4. And the fact that it's 1/3 means it's actually going to be pretty wide. It's going to be not as narrow. It's going to be wide like this. And it is going to be going up because the a is positive. So that's a lot of things we'll talk about in the future. This one just straight up isn't a function. You can clearly see the vertical line test. If you draw a vertical line, you can hit no domain's allowed to have 2 ranges. So no vertical line should be able to hit the function twice at the same time. All right, this one's linear. I know what you're thinking. That one looks quadratic. It looks a lot like this one. But look at number 4 and then look at number 6. You'll notice that there's no squared here. So it's not x squared. This is actually linear. It is a function. So the type of growth in this case, so we've got a linear function that looks like it's been slid 2 to the right and 4 up. And it's going at a rate of change of up 1, right 3, up 1, right 3, up 1, right 3. So it's going, and what type of growth is? So it's increasing. It's increasing up 1, right 3. Right, number 7, a relationship between the speed of the car and the distance it travels to take the stop and traveling at that speed. So first of all, is it a function? Yes, because I don't see any of the domains have any ranges. I'm sorry, none of the domains have more than one range. What type of function? Now I need to really look close here at the numbers. And it's looking to me like the numbers are getting pretty high pretty fast. So that rules out linear. So exponential times. So that would be times about 3, but no, that's actually not times 3. And that's definitely not times 3. So I think I can rule out exponential as well. So then the last thing I would need to do is look at, is there a second difference? Well, what is the difference between these two numbers? So that would be 36 minus 12, that makes 24. So that's actually 23 and a half. So it adds 23 and a half. Then is that adding 23 and a half? 3, 4, 5 plus 3. Yes, it is. Plus 23 and a half. Plus 23 and a half. No, that is not plus 23 and a half. So I'm seeing, I'm not sure if this is an error or not. But this one's increasing 23 and a half, and this one looks also to be increasing 23 and a half. So maybe this is, okay, so it's not linear, it's not exponential, it's not quadratic, so it's none of the above. I'm just going to say that. It looks like it's going up linear to begin with, and then it's changing to something else. All right, so is this one a function? Yes, it is, because no domain has more than one range. It goes from 1 dot to 3 dots to 3, 4, 5, 6 dots to 1, 2, 3, 4, 5, 6, 7, 8, 9 to 10 dots. So that looks like plus 2, plus 3, plus 4. So that's definitely quadratic. The rate at which caffeine is eliminated of adult is about 15% per hour. Now, you're going to notice that exponential growth and decay is the only time when we've done that it has percent involved. So if it's 15%, so the bloodstream of an adult is about 15% per hour. The relationship between the amount of caffeine in the bloodstream and the number of hours from the time the adult drinks the caffeinated beverage. So that's going to be exponential because we're talking about percent of change, which means you're multiplying geometric sequence. Exponential, I'm going to say this one's linear because you can clearly see it's a straight line. This one is quadratic, and the reason being is because when you use the FOIL method, first, outer, inner, last, you're going to get x times x, so that's really 4x squared. Anytime you have x squared, it's quadratic. Question number 12. Mary Contrary wants to build a rectangular flower garden. Okay, walkway is 4 meters wide, and the flower garden will be 6 meters long, then it is wide. The relationship between the width of the garden and the perimeter of the walkway. All right, so the perimeter of the walkway, so I believe that was going to be that's going to be linear for A, and it's going to be quadratic because area has a quadratic relationship with one of the widths. So that actually has two different answers. 13, exponential, clearly because x is an exponent. Quadratic, you can clearly see it goes up. Ooh, I can hardly see those numbers. 5, so it looks like up 2, then up maybe 3, then up 5. So it looks like it's plus 1. Second difference of plus 1, but it was kind of hard to tell. All right, question, homework. Here we go. I had 81 freckles on my nose before I began using vanishing cream. After the first week, I only had 27, and the next week I had 9, and then 3. What kind of function is that? Well, that is exponential. And yes, it is a function. How do I know that? Because no domain has more than one range. Describe the first differences. So I'm now noticing that this is, I'm just going to write the equation. The starting point would have been, so let's see, after week, I had 27. So at the beginning, I had 81. So that would be 3. The rate would be, so it's 81 to start with. Starting point times rate to the power of x. Now the rate would be times 1/3 to the power of x. And 81 was the starting point. I'm assuming that's the 0th term and not the first term. So I'm just under that assumption. Make a graph and label your axes of the scale. Show all 4 points. Now that's going to be pretty difficult here. If I'm going to have to start at 81, I'm going to need to go by like 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. So 81's about right there. You're going to have to do your own labels yourself. The next one would be 27, so it's probably going to be like somewhere around there. And then it gets smaller and then smaller. So it's going to end up looking something like that. Now, you're going to have to just be more precise because I'm already at 10 minutes anyway. Sorry. You're just going to have to do that yourself. Start at 81 and then go down to 27 and then go down to 9, then 3, and so forth. I don't think I curved mine as much as you should have. It probably was more like that. Okay, so I'm going to erase that evidence because that was pitiful the way I drew that. So 81, it would have looked... It's going to go down real fast. It's exponential decay. All right, last one. 81 to 80 and 2/3 to 80 and 1/3. It looks to me like it's decreasing by 1/3. So that would be y. That'd be linear. So it's negative 1/3 x plus the starting point, which is 81. That's the equation. That's definitely linear. And that is definitely a function because no domain has more than one answer. Write an explicit equation. Oh, I believe I just did that. Describe the first differences. It looks like it's subtracting 1/3. All right, that's a wrap. That's another video in the books. Please give it a like if it helped you learn something. And definitely watch future videos and subscribe. Thanks for watching. Have a great day.